In this video, I will be explaining the excitation-contraction coupling sequence. The connection between the stimulation of a muscle fiber and a contraction is called the excitation-contraction coupling. It starts out with an action potential that's conducted down a motor neuron axon. The motor neuron terminal releases the neurotransmitter acetylcholine. The neuromuscular junction is the synapse where a motor neuron and muscular fiber meet. The acetylcholine binds to the acetylcholine receptors on the muscle fiber. The motor end plate is stimulated. An action potential is generated in the adjacent area of the sarcolemma, and the impulse is conducted over the surface of the muscle fiber and deep into the fiber through the T-tubules. When the impulse reaches the SR, the DHP receptor functions as the voltage sensor which controls the release of calcium from the SR. Calcium ions diffuse from the sarcoplasmic reticulum into the cytosol and bind to the tropin molecules. The RYR receptor is responsible for the release of calcium from the SR. Tropomyosin molecules move and expose specific sites on actin where myosin heads can bind. Cross bridges form, linking the thick and thin filaments. Thick or actin filaments are pulled towards the center of the sarcomeres by pulling off the cross bridges, which increases the overlap of the thick and thin filaments. The muscle fiber then shortens as the contraction occurs. For relaxation, acetylcholinesterase decomposes acetylcholine and the muscle fiber membrane is no longer stimulated. Calcium ions are actively transported from the plasmalemma because of its permeability into the sarcoplasmic reticulum. ATP breaks cross-bridge linkages between actin and myosin filaments without the breakdown of ATP itself. The myosin heads contain SERCA, which catalyzes the breakdown of ATP to ADP. The breakdown of ATP cocks the myosin heads up. Troponin and tropomyosin molecules block the interaction between myosin and actin filaments. The muscle fiber remains relaxed, but it is also ready for contraction again.